Okay, here we go. That's my ID. Let me turn the camera on so you can see. Excuse the dog. I'm sorry. But, okay, here's my presentation. The life cycle of a star. Okay, the first question is, what is a star? Stars are hot bodies of glowing gas that star as a nebula. Stars vary in size, mass, and temperature. The color of a star is determined by its temperature. Okay, and I added this picture in here into the slide because this basically is a diagram of how the star cycle is actually created, really. I mean, it starts off as the nebula and then it varies. But this basically, I added this because it's going to lead into what I'm finna get into next. Okay, nebula. A nebula is a giant cloud of dust and gas. Some nebula comes from gas and dust thrown out by the explosion of a dying star. Other nebulas are regions where new stars are beginning to form. These nebulas can come together to form stars under the power of its own gravity. As it begins to become more uniform, it is called a protostar. A protostar is formed as gravity begins to pull the gas together into a ball. A star is not truly a star until it can fuse hydrogen into helium. Before that, they are called protostars. So, main sequence stars. Main sequence stars fuse hydrogen atoms to form helium atoms into their cores. About 90% of the stars in the universe, including the sun, are main sequence stars. These stars can range from about a tenth of the mass of the sun up to 200 times as massive. The term main sequence comes from the Hertzsprung-Russell diagram, in which scientists plot the absolute magnitude of stars against their color. Okay, and this is a picture of the Hertzsprung-Russell diagram, basically. I added that in there. Okay, and now I'm going to just basically break down exactly what I just showed you. The Hertzsprung-Russell diagram, it was developed in the early 1900s by Ignor Hertzsprung and Henry Norris Russell. It plots the temperature of stars against their, I still have a hard time with their luminosity, or the color of stars against their absolute magnitude. Depending on its initial mass, every star goes through specific evolutionary stages indicated by its internal structure and how it produces energy. Each of these stages corresponds to a change in the temperature and the luminosity of the star, which can be seen to move different regions on the HR diagram as it evolves. Okay, now going back to that life cycle of a star. The next step from the nebula is the average star. An average star is a star with an initial mass of 0.5 to 8 times of the sun. An average star proceeds through 3 major life stages. Okay, the red giant. A red giant star is a dying star in the last stages of its evolution. Red giant stars reach sizes of 100 million to 1 billion kilometers in diameter. 100 to 1,000 times the size of the sun today, which is the red giant. Okay, next, the planetary nebula. Planetary nebula are cloudy remnants of smaller stars that have shed their outer layer of gas but has not exploded into the supernova. The lifetime of abbreviated P&E are relatively short, on the order of 200,000 years, so they are rare, which about 1,500 known in the galaxy. William Herschel called these spherical clouds planetary nebula because they were round like the planets. At the center of a P&E, the glowing leftover central parts of the star from which it came can usually be seen. Okay, the white dwarf. A white dwarf is what stars like the sun become after they have exhausted their nuclear fuel. White dwarfs are the dying of an average star. No fusion takes place inside a white dwarf. Okay, this is the end of the average star's life. Now, basically, if the protostar becomes a massive star instead of an average star, it has a different life cycle. So, meaning the star starts off as a nebula, but like I said, if it takes the route of an average star, what I just showed you is the process. But if it becomes a massive star, there's a totally different process, which I'm finna explain. A massive star. A massive star is larger than 8 solar masses during its regular main sequence lifetime. Massive stars are born just like an average star. If the cloud of dust is large, it creates a massive star. A star is considered massive if it's at least 8 times more massive than our own sun. Okay, this is a lot. The red supergiant is what's next. A red supergiant is an aging giant star that has consumed its core supply of hydrogen fuel. Helium has accumulated in the core, and hydrogen is not undergoing nuclear fusion in the outer shells. These shells expand, and the now colored star that takes on a red color, they are the largest known stars. Okay. Apart from the increasing size and changing color, red supergiant stars kick off the fusion in their cores again. The helium that accumulated during their main sequence phase begins to fuse into carbon. When the pressure gets high enough, the carbon will fuse into oxygen, and these changes will continue as a heavier and heavier elements as fuel. Okay. Supernova. A supernova is the explosion of a star. It is the largest explosion that takes place inside space. A supernova happens where there is a change in the core or center of a star. A change can occur in 2 ways. The first type is binary system, which are 2 stars that orbit the same point. One of these stars steals matter from its companion star, eventually accumulating too much matter, causing it to explode. The second type is a star running out of nuclear fuel. Some masses flows into its core. Eventually, the core is so heavy that it cannot withstand its own gravitational force, causing a giant explode. Okay, the last, excuse me, the last process is the neutron star, or what we call the black hole. It has 2 words for it, actually, but I was surprised that it has 2 different meanings. When the most massive star dies, they collapse under their own gravity and leave behind, which is black holes. When stars that are a bit less massive than this die, they explode and leave behind dense, dead remnants of stars called neutron stars. So, really, basically, you could typically say that they're both the same as far as ending in the results. They both die. It's the last stages of a star, just 2 different ways. But that, I believe that's it. Yeah, that's it. But yeah, that was my presentation of life cycle of a star. Doing this presentation, I came across a lot of information that I absolutely didn't even know myself. But the life cycle of a star was very interesting to me. Like I said, I found out a whole lot of information on actually how our stars are operated, and we see so many stars in the sky at nighttime, but yet we, speaking for myself, didn't know the process of, of one, how they able to be up there like that, and then where did they come from, the whole process. But yeah, that concludes my presentation. Thank you for listening.